Hi, in this video we are going to talk about pre-order traversal of a given binary tree. In pre-order traversal, we process the root first or we print the root key first. Then we process the left subtree completely and then we process the right subtree completely. So we have followed the same idea in the implementation. If you take a look at these implementations, C++ and Java for the same thing, what are we doing here? We are printing the root arrow key or root dot key first. Then we are recursively calling for the left subtree. Then we are recursively calling for the right subtree. One thing you can notice is both of these codes have this condition if root is not null, which makes a lot of sense because if you pass an empty root or a null root and if you call null dot key or null arrow key, you will get runtime error. So to avoid this, we must check whether root is null or not null. If root is not null, then only we process and do these three steps. So the idea is simple. You have root, you have left subtree completely on the left side of it and you have complete right subtree. So you print the root, you recursively call for the left subtree and print the left subtree completely using the same thing, and then you print the right subtree completely using the same idea. So how does this recursive code work? Let's see it with this example. We have this tree and pre-order traversal of this tree is 10, 20, 30, 40, 50. How are we getting this pre-order traversal? We are printing the root first and then we are printing the complete left subtree. So we have 20, then we are printing the complete right subtree. So we have 30, 40 and 50. How does this recursive code work? We call this for root. Right, so pre-order is called for 10. Here 10 needs address of 10 or reference of 10, address in C or C++ and reference in Java or Python. So we call it for 10 and your code begins its execution from the first line. It's not null, so it's going to go inside this if condition. And what does it do inside this if condition? It prints root arrow key or root dot key. So we see 10 on the screen. After 10 is printed on the screen, what it does? It recursively calls for the left subtree. So it's going to call for 20. So after calling for 20, what happens? Again, the recursive code is executed from the first line for a new root, which is 20. And when you execute it from the first line, first thing it does, it checks whether it is null or not. It's not null. So it's going to go inside and execute those three lines. And what is it going to do? It's going to print 20 on the screen first, and then it's going to recursively call for left of 20 and right of 20. So left of 20 is null. It will make a recursive call for null. When it makes a recursive call for null, what happens? Root not equal to null condition does not pass. You do not go inside this if condition. You come out, you finish the function, because when root is null, there is nothing to do. So this function call is over. It gives the control back to the caller. And caller, which was executing call for the left subtree, now has finished this, and now it will execute the next line, which is the last line here, and this line is to call for the right subtree, and right of root is 20 is also null. So it's going to make a call for null again, and this call is also going to finish immediately. So 20, when you called, it has done all the three things. It has printed itself, it has called for the left subtree, called for the right subtree, it finishes and gives the control back to the caller. Now the caller, which is pre-order 10, it had printed 10, it had called for 20, now it's going to call for the right child. The caller was waiting for the left call to finish here or here in Java. Now the left call is finished, so it's going to execute the right call, or it's going to make a recursive call for the right call. And right call is for pre-order 30. So pre-order 30, what you will do? It will print 30 first, then it will make a recursive call for 40. 40 will print 40, will make a recursive call for null and null. They'll finish immediately and they'll give the control back to 40, and 40 has nothing else to do. So it's going to finish and give the control back to the caller, and caller is now going to make a call for the right child, and right child call is going to print 50 and then going to call for null and null, and these two are not going to do anything. So this is also finished. So pre-order 30 is finished. And pre-order 30 is finished, then pre-order 10 is also finished, because right child is the last thing that every recursion is doing. So this is how this recursion works. This is how you get this output on the screen: 10, 20, 30, 40 and 50. Let us now quickly talk about time complexity and auxiliary space. Time complexity and auxiliary space analysis of pre-order are same as in order. We are going to do constant amount of work for every node. That is how the time complexity is big O of n. And there are going to be big O of h recursive function calls at any moment. So the auxiliary space is big O of h.